here, and let's get this party started with double angle and half angle formulas. You're excited, I can tell. All right, so let's see what we got going on here, if I can get my pointer. So let's actually derive these, and we're going to use the formulas that we used, our sum formulas from the last section. So if I have my sine alpha plus beta, remember that was sine alpha cosine beta plus cosine alpha sine beta. Remember that? That's the sum formula. Well, if I want to find a double angle, like 2 times theta, well, isn't that the same thing as sine of theta plus theta? Because if you got one theta and you got another theta, you got 2 thetas. That's that higher math. And so from here now, I can just use my formula. So I get sine theta cosine theta plus cosine theta sine theta. And then, of course, these being the same gives me 2 sine theta cosine theta. So that's my double angle formula for sine. Well, let's look at the cosine. So if I have cosine alpha plus beta, my sum formula. Remember this from last section, cosine alpha, cosine beta. Remember this one, the signs change, so minus sine alpha sine beta. All right, good to go. Let's look at the double angle. So cosine 2 theta. I was going to say my students in class normally say, Cindy, slow down, but y'all can't say that because you can hit pause when I go too fast. So I have cosine theta plus theta. And now I write it out like Lagadish up here. So I have cosine theta minus sine theta sine theta. Multiplying those out give cosine squared theta minus sine squared theta. All right, and let's get another color. And just as a reminder, kind of over here on this side, is that sine squared theta plus cosine squared theta equals 1. We've been using that identity a lot, so you should remember it by now, right? Let's solve this for sine squared theta. So equals 1 minus cosine squared theta. So going back over here, get my purple, is then we could also say cosine 2 theta equals cosine squared theta minus, where I see sine squared, I'm going to put the 1 minus cosine squared theta. And so, of course, this gives me cosine squared theta, distributing this negative sign, minus 1 plus cosine squared theta, which would just simply be 2 cosine squared theta minus 1. And then doing the same thing over on the side once again, get my red, is I could have solved this for cosine squared, right? Cosine squared theta equal, what happened? Shoo! Equals 1 minus sine squared theta. So I could have done that, right? I could have solved it for cosine instead. And then going back over here, if I can get me some room, then that also means cosine 2 theta, going through all the steps of plugging in 1 minus sine squared theta for cosine. and then minus sine squared theta, we can see that we get 1 minus 2 sine squared theta. All right, so all I've done is I took the sum formulas and I derived these double angle formulas. Pretty exciting, right? And so as you will see, there they are. And so the big question, you know, with students is always, well, how do I know which one to use? Well, a lot of times it's what you're given, what's the easier one to use. With the cosine, you see sine double angle only has one. So let's try one of these. Let's find the exact value of sine 2 theta if sine theta is 3/5, and it looks like we're in quadrant 2 between pi over 2 and pi. So my formula, sine 2 theta equals 2 sine, I guess you could see it up there at the top, but my point is, I don't know what that is. So I gotta find that. So let's find cosine theta by using, guess what? Sine squared theta plus cosine squared theta equals 1. That identity is definitely your best friend. So cosine squared theta equals 1 minus sine squared theta. And so cosine theta equals square root of 1 minus sine squared theta. And I can see I'm in, as I mentioned up here, in quadrant 2, and cosine is negative in quadrant 2. So all I have to do is plug in, which I probably could have done it up here, less steps, but we like lots of steps. Plug in my 1 minus, and my sine is 3/5, right? So cosine theta equals minus, just go ahead and turn 1 into 25 over 25, minus 9 over 25, just got a common denominator. And cosine equals 16 over 25. How nice. And that becomes negative 4/5. So now all we have to do is go back here and put 2 times the sine, which is 3/5, and the cosine, which is negative 4/5. And if I multiply all that out, I get 2 times 3 is 6, 6 times 4 is 24, and that's negative over 25. All right, so using the sine double angle formula. We'll continue next with more examples.